right? We actually say which components in the application are responsible for doing those security features. It's documented. Yes, it's more documentation, but that becomes important as the application evolves, right? It speaks to design development people at a language they understand. It's not some security language, and it's not involving a whole bunch of components that are outside of their scope. It's stuff that they understand, that they work with, right? And you're getting to the actual component or even object class level, right? And perhaps more importantly, once it's created, right, it can be taken by the developers and extended, right? They have this. And now when they design new features in the applications or when new attacks come out, they can look at the application design and say, hey, we have input validation over here. Let's review this input validation component and see if we're actually protected against this attack. Or we're going to add a new interface into the application. What components do we have to build into it from a security perspective, right? You actually have it documented at a design level, and developers can maintain it as the code base changes. Security features are there for a quick reference, right? So one of the more important things is it's a cost saver. If you are a person who does code reviews, you do this while you're doing the code review, right? Then there's not as much additional time because you need to do this all in your head anyway. So this is documenting it, right? Then the next time you do a code review, you don't waste time, or as much time at least, on the components that you know are not relevant to security, right? You're actually saying these are the components that are relevant to security. And yes, there are other things you need to look for, like I said, synchronization, et cetera. But you can focus the initial time on the components that are most important to you as a source code reviewer, right? So this actually becomes a time-saving mechanism as the application evolves. So drawbacks, you need to really understand the code, really understand it, right? Like you need to look at that source code, or you need to have a very deep understanding of the design. This is not something that you can just whip up, right? And it's not intended to be. We already have that, right? We have threat modeling. This is really for the focused, in-depth review. It's more time-consuming. It's actually about twice as time-consuming as a traditional threat model, meaning realistically, you need to do this while you're doing source code review. If you try and do it on your own, you're going to get shot down, right? No one's going to give you the time to do it. But unless you have a very kind of proactive security company and they understand the benefit here. But while you're doing source code review is the best time to actually look at this. And you're going to spend more time meeting with clients to understand things. Okay, that's whether clients means you're an external consultant, or whether it means you're the security person or the developer talking to, say, the business people in the company. Whatever it is, there's going to be some more time spent on that. There's no tool support for it, right? I mean, there's UML diagrams, but there's no Microsoft analysis, the Microsoft threat modeling tool. It doesn't really go to this level, right? That's a drawback. The other thing to keep in mind is that this is a very narrow view of security. It doesn't talk about holistic security on purpose, right? You will not catch patch management or poorly configured SSL or anything like that at this level. That has to be done separately, right? But usually that's how it's being done anyway within a company.
Quick question.
Sure.
You said there is no tool support for it.
Yes.
It
Being this design level threat analysis. So there is UML tools, but this entire process doesn't have a tool.
I can say that if I identify a clear pattern here,
Mm-hmm.
there are tools out there that can help me enforce, at least from my doctrine that we have tools in which you can define rules.
Yes.
That will help me enforce the use of those patterns.
So in the source code review part of it, you're talking about?
Both development and source code review.
Both the what, sorry?
Both development time, for developer to use it, and the source code review time by the review.
Right, so but I mean, yes, you have rules that you can apply on the code itself that actually do the analysis on the design. That's not something where we have tools in, but there are, UML checkers, or you can check for certain constraints and that kind of thing. But realistically, to do this process right now, it's not there.
Talking just as a process, as a design.
Yes.
If I have a picture out there, you don't have a tool that will say, okay.
You have tools that will help you
Okay.
to find the security features which is obviously very important, but that again gets into source code review, which is not what I'm talking about here, not doing source code review itself. So we need to remember both that this, or rather we need to remember that this is a very narrow view, right? And this is not supposed to, it's not supposed to be in place of things like penetration testing or anything like that.
Just to make it clear for me, are you saying we should use this more fine-grained model, both for the threat modeling part and for the countermeasure, assigning countermeasures, or only for countermeasures?
So what I'm saying is this is actually independent of the threat modeling component that most organizations already do. In fact, I'm not even sure this should be called threat modeling. That's why I said this should really be done as part of source code review.
So from the threat modeling, we get the list of the countermeasures we need, and then we assign them on this more fine-grained module.
Yeah, you could certainly